Welcome to the deep dive. Today we're jumping into the pretty exciting worlds of VR, AR, MR, and the metaverse.
That's right.
We've gone through a whole stack of material academic papers, news clips, product info, basically everything we could find.
A real mix.
And the goal here is to pull out the key stuff for you, quickly and clearly, without getting lost in the weeds. You want the insights, we've got them.
And it's needed, because this field is just exploding. One source called it a Cambrian explosion of innovation.
A Cambrian explosion, wow. So lots happening very fast.
Exactly. Think about it. The market was already nearly US $16 billion back in 2020.
16 billion.
Yep. And it's projected to grow like 18% a year until 2028. That's huge growth.
Okay, that's definitely significant. So let's start with the basics. VR, AR, MR, they get thrown around a lot. What's the actual difference?
Good place to start. Fundamentally, there are different ways of blending digital stuff with our reality.
Okay.
Virtual reality, VR, is probably the most well-known. It basically shuts out the real world completely.
Total immersion.
Total immersion. You put on a headset, like, say, an Oculus Rift, and you're in a computer-generated world. It tries to replicate realistic sensations, sights, sounds.
Right, so you're somewhere else entirely. Then what's augmented reality AR? That feels more common now, like on phones.
Precisely. AR doesn't replace your view, it adds to it. It overlays digital information onto your live view of the real world.
Like those Google Maps walking directions that show arrows on the actual street.
Perfect example. It enhances reality, doesn't replace it.
Okay, so VR replaces, AR enhances. Where does mixed reality MR fit in? Is it just fancy AR?
It's a step beyond AR, you could say. In MR, the virtual objects aren't just overlaid, they actually appear to interact with the real world.
Interact how?
Like, a virtual ball could bounce off your real table, or a digital screen could seem fixed to your actual wall. Microsoft HoloLens is the classic example here.
Okay, so the virtual things understand the physical space.
Exactly. They're anchored to it and can react to it. It's a true mix.
VR total immersion, AR digital layer, MR interactive digital layer.
Got it. Now, you mentioned something called presence earlier. That came up a lot in the research. Why is that such a big deal, especially for VR?
Presence. Yeah, that's kind of the holy grail for VR. It's not just about the tech working. It's the feeling.
The feeling.
The psychological sense that you are actually there inside the virtual environment. Not just looking at a screen, but truly inhabiting that space.
Okay, so it's about tricking your brain, essentially.
In a way, yes. The sources make a useful distinction between immersion and presence.
Right. They aren't the same thing.
Not quite. Immersion is what the technology delivers, the vivid visuals, the 3D audio, the wide field of view. It's the objective quality of the illusion.
So, high-res graphics, good sound. That's immersion.
Yeah. And high immersion often leads to a stronger sense of presence, but presence itself is your subjective feeling, your psychological response to that immersion.
I see. So what factors actually boost that feeling of presence? What makes it more likely you'll feel like you're really there? Well, the research points to a few key things.
Yeah.
One is vividness, basically how rich and detailed the sensory input is. Better graphics, better sound, more senses involved.
Makes sense. More realistic input, more believable world.
Right. Then there's the idea of having a virtual body. Seeing some kind of representation of yourself, like virtual hands or a full avatar.
Seeing yourself in the game.
Exactly. That really seems to anchor you in the virtual space, makes you feel embodied there.
Interesting. What else?
Your own internal factors matter too. Some people just seem more susceptible to feeling present than others. Personality, previous experiences.
So it varies person to person.
Definitely. And interactivity is huge. The more you can meaningfully interact with the virtual world, touch things, move things, influence things, the more real it feels.
Right, being an active participant, not just a passive observer.
Precisely. And finally, just overall sensory factors and realism. Does the world behave consistently? Do things look and sound believable? All that contributes.
So vividness, a virtual body, interactivity, realism, and even individual differences. It's a complex mix. Let's step back a bit. The sources mentioned some really early VR tech. Yeah. What was that like compared to now?
Oh, night and day, really. We're talking maybe 30 years ago, things like the UNC head-mounted display. Big, clunky.
Something like that?
Incredibly. They mentioned a position sensor, the behemoth tracker, that cost like US $2,000 back then.
$2,000. Just for the sensor.
Just the sensor. And early displays often used things like small LCD TV screens, also pricey. You needed multiple components, all expensive.
Wow. Really puts today's consumer headsets in perspective. So that leads into this Cambrian explosion you mentioned earlier, around 2014, 2015. What kicked that off?
It was a confluence of things, really, but a huge catalyst was Facebook buying Oculus.
Right, for US $2 billion. That sent a shockwave.
Absolutely. It signaled that major players saw huge potential. Suddenly, VR wasn't just a niche research thing anymore.
What else happened around them?
We had Google Cardboard appear. Super cheap, using your smartphone.
Yeah, I remember those. Made a cardboard, right?
That's the one. Sold 500,000 in a week or something crazy like that.
Yeah.
It made basic VR accessible to almost anyone.
Showed there was massive public curiosity.
Totally. And then you also had Magic Leap getting huge funding, generating buzz around mixed reality.
Ah, Magic Leap, yeah. Lots of mystery there for a while.
And Microsoft announced HoloLens, really showing off a polished vision for Missar. So yeah, a real explosion of activity and investment.
Okay, so things took off, but it's not all smooth sailing. The sources highlight some big challenges still facing VR, AR, and MISHA. What are the main roadblocks?
Yeah, the tech is still evolving. 4 major hurdles were pointed out. First up, display resolution.
Getting sharper images.
Sharper and wider field of view without seeing the pixels. You know the screen door effect where you can see the gaps?
Kills the immersion.
Exactly. Current resolutions like 2160 by 1200 are decent, but for a truly convincing wide view like 110 degrees, it's not quite enough. Some suggest we might eventually need something like 10K by 10K per eye.
10,000 by 10,000. That's a lot of pixels.
A massive jump, but maybe necessary for true visual realism. The second big one is latency.
The delay.
Yeah, the lag between when you move your head and when the image updates. It has to be low.
Why low? What happens if it's not?
Dizziness, nausea, basically VR sickness. Your eyes are seeing movement, but your inner ear isn't feeling it quite right, or there's a noticeable delay. The target is generally under 20 to 50 milliseconds.
Okay, crucial for comfort then. What are the other two?
Third is focus. Most current headsets have a fixed focal distance. Everything appears sharp at, say, 2 meters away.
But that's not how our eyes work, right? We refocus constantly.
Exactly. So having a fixed focus can lead to eye strain, and it just doesn't feel quite natural. Variable focus displays are a big research area.
Makes sense. And the last one?
Registration. This is mainly for AR and MR. It's about making sure the virtual objects line up perfectly with the real world and stay lined up as you move.
Ah, so the virtual couch doesn't drift across your real living room floor.
Precisely. Getting that alignment accurate and stable is really tricky, especially outdoors or in complex environments.
Okay, so resolution, latency, focus, and registration. Lots to work on. Let's talk about some specific gear and what people are actually doing with this stuff. The sources mentioned quite a few examples.
Yeah, definitely. On the VR side, you've got headsets like the HTC Vive, known for its tracking uses like 70 sensors or something.
70? Wow.
Yeah, allows for really precise room scale tracking, maybe up to 15 by 15 feet. Pretty good resolution per eye, too, 1080 by 1200, and a 90 hertz refresh rate, which helps with that latency issue.
And the Oculus Rift. Still a major player.
Oh, yeah. Similar specs in many ways, maybe a slightly smaller field of view, around 96 degrees. Also uses tiny MEMS sensors for tracking its latency under 20 meters, and it has adjustments for focus and the distance between your pupils, IPD, which helps with the comfort.
Right, getting the fit right. What about HoloLens again? You said it's MR, optical see-through.
Yeah, Microsoft HoloLens is different. It's a full holographic computer you wear. It maps the room around you, spatial mapping, so it knows where walls and furniture are.
And then it projects holograms onto the see-through lenses.
Exactly. And you can interact using gestures, voice commands. It's really designed for professional applications, design, training.
And on the more accessible end, you mentioned Google's Daydream.
Right, Daydream View VR. That used specific Android phones, like Google's Pixel phones, slipped into a lightweight headset, had about a 90-degree field of view, simple controller, more basic, but easy to use.
And those Lenovo AR headsets, Star Wars and Marvel.
Yeah, the Lenovo Mirage AR, those are smartphone-powered AR examples. You slot your phone in, and it uses mirrors and tracking to project interactive AR experiences, like fighting with a lightsaber.
Fun. But it's not just games, is it? The sources mentioned professional uses, like in construction.
Absolutely. AEC architecture, engineering, and construction is a big one. Being able to visualize a building design in 3D, walk through it virtually, spot clashes. It's incredibly useful.
I can see that. Saves costly mistakes down the line.
For sure. The Calix CEO mentioned this, highlighting how it streamlines workflows.
Any specific VR games or experiences that stood out in the materials?
A few were mentioned, things like Star Trek Bridge Crew, which is a collaborative game putting you on the bridge of a starship.
Sounds cool.
Yeah. And then simpler things like VR roller coasters or experiencing dinosaurs in VR. Lots of entertainment stuff on mobile platforms too, Android and iOS.
And you don't always need purpose-built VR apps, right? YouTube and Street View.
Correct. YouTube has tons of 3D and 360-degree VR videos now. Just search 3D trailers or 360 VR.
Easy way to try it out.
And Google Street View in VR mode is amazing. You can just transport yourself to almost anywhere on Earth and look around immersively. Stand in Times Square, walk the Great Wall.
That's pretty incredible. What about some of the really high-end, maybe surprising applications? Medicine came up.
Yes, the Da Vinci surgical system. It's a sophisticated robotic system where the surgeon sits at a console looking at a magnified 3D view and controls tiny robotic arms to perform surgery with incredible precision.
So the surgeon is using a form of VR or enhanced view to control robots.
Essentially, yes. It's about enhanced visualization and dexterity. The source even noted, surprisingly, quite a few of these systems are in Taiwan.
Wow. And industry uses too, like designing cars.
Definitely. NVIDIA's holodeck system was mentioned. It's like a virtual collaboration space for designers and engineers. They can import complex 3D models, walk around them, interact with them together, even if they're in different countries.
Like a shared virtual workshop.
Exactly. And BMW is using NVIDIA's Omniverse platform to create a digital twin of their factory.
A digital copy of the whole factory.
Pretty much. They can simulate changes, test workflows, train robots virtually, optimize everything before changing the real factory. They reported something like a 30% efficiency boost.
30%. That's huge. Okay, so we've covered sight, sound, interaction. But what about other senses? Are they coming to VR too?
They're working on it. Audio is already pretty advanced, with 3D spatial audio trying to match our natural hearing capabilities. MEMS speakers are helping there too.
And touch.
Yeah.
Haptics. That seems vital for really feeling present.
Absolutely. We're familiar with basic haptics, like the vibration on our phones. The iPhone's Taptic engine is quite sophisticated.
Right, that little buzz.
But for VR, they're aiming higher. Think haptic gloves. Companies like Haptex are making gloves with like 133 tiny actuators per hand.
Whoa, what does that feel like?
It aims to simulate pressure, texture, shape, so you could feel like you're actually holding a virtual object, feeling its contours.
That would be a game changer for immersion. What about smell? That seems really hard.
It is tricky. Our sense of smell is incredibly complex. Apparently, we can distinguish maybe 1 trillion odors.
1 trillion, wow.
Yeah. But there are companies trying. Vaxo VR makes a device that attaches to a headset and releases scents from cartridges. They have maybe 5 scent types now, still early days.
Flowers, gunpowder, coffee.
Things like that, yeah. Adds another layer. And taste. Well, that's mentioned as another frontier, even further out, probably.
Fascinating. So bringing all this together, maybe standardizing it, the sources mentioned an IE standard, 2880.
Right, IE 2888. That's looking towards the future, towards digital twins and the metaverse. It's trying to create a common framework, an architecture.
For what purpose?
To allow different virtual spaces and objects, especially those linked to real-world sensors or data, like that digital twin factory, to work together more easily. Standardization helps things connect and interact seamlessly.
So laying the groundwork for these complex virtual worlds to actually connect and function together.
That's the idea, building the foundational plumbing for the metaverse, if you like.
Makes sense. Looking at all these developments and challenges, what do you think is the most critical breakthrough we need next to really push VR forward?
That's tough. Latency is always vital for comfort. But honestly, I think major improvements in display technology, getting that resolution way up and field of view wider without making headsets heavier or crazy expensive, that could be the thing that really unlocks the next level of widespread adoption and realism.
Yeah, better visuals without the screen door effect or tunnel vision.
Yeah.
I can see that making a huge difference. Well, this has been incredibly insightful. We've covered a lot of ground,
We certainly have.
from the basic definitions of VR, AR, and MR, to why that feeling of presence matters so much.
The history, that Cambrian explosion, the big technical hurdles still ahead.
All the diverse applications,
Yeah.
from games to surgery to factory design.
And even touching on bringing in more senses and the
Yeah.
need for standards.
It really gives you a solid picture of where this technology is and where it might be heading. It's moving fast.
It really is an exciting and complex field to watch. Hopefully this gives you a good handle on the key aspects.
Absolutely. So, to leave you with something to think about, considering everything we've discussed today, the tech, the challenges, the potential, what applications of VR, AR, or MR, things that maybe seem like science fiction now, do you think could actually become commonplace in our daily lives over the next, say, 10 years? And what kind of ethical questions might pop up as these worlds become more integrated with our own? Something to chew on. Thanks for joining us for this deep dive.